And third, the task is MLQA. It is multilingual question answering task. So basically, given a questions, you have to find the answer in the context. So this is the task, and they create the same questions, same question answer pair in different languages also, and they create this kind of pairs, about 5K QA pairs for 7 different languages. And this is the result. So even though XNLI can cover about 100 languages, they achieve the state-of-the-art compared to the previous methods. And the second result is NER, and third result is MLQA. As you can see, it is better than the previous approach. But we will explain in more details in the next sections.
Okay. Before going to the details for performance of XLMI model, I'm going to talk about the result of analysis to find optimal settings for multilingual masked language models. There are a lot of different and important factors, like such as number of language, model capacity, and so on like this, to improve multilingual masked language models. First of all, I will explain about the number of languages and the capacity of models. As you can see in the left figure, from 7 languages to 15 languages, the model can take advantage of positive transfer to improve performance, especially on low resource languages. However, after 15 languages, the performance is slowly going down. Yeah. So this issue is called the curse of multilinguality. This kind of issue is more prominent when the capacity of the model is small, as you can see in the right figure. To resolve this issue, XLMI model is trained with a large transformer with 24 layers and 1024 hidden test states. Secondly, I will explain about the effect of sampling rate between high resource and low resource languages. The sampling rate is controlled by the alpha parameter. So as you can see in this figure, when the value of alpha is higher, the performance on high resource languages is going up. However, it is going down on low resource languages. So to consider overall performance in high resource language and low resource languages, the XLMI model is trained using 0.3 alpha parameter. Next one is about the importance of vocabulary size. Scaling the size of the shared vocabulary can improve the performance on downstream tasks. As you can see in this figure, however, with a fixed capacity after a vocabulary of 256K, the accuracy is going down. So for that reason, the XLMI model is trained using a vocabulary of 250K. Next one is about the scale of the dataset for training. The XLMI model is trained using Common Core corpus, which is larger than Wikipedia corpus. As you can see this figure, all models trained on Common Core obtain better performance than the models which is trained using Wikipedia corpus. Lastly, I will explain about the batch size and tokenization. Similar to the large scale training, the larger batch size is better, as you can see in the left side of this figure. So the XLMI model is trained using 8,192 batch size, and XLMI model uses sentence piece model to simplify multilingual tokenization. As you can see in the right side of this figure, when using the SPM, there is no loss in performance compared to models trained using byte pairing code. my presentation ends here. Next, Jung-Yun will explain about the detail of performance of XLM RO.
Thank you, Jason. I'll continue with the two analysis about the cross-lingual model performance, and the other one is does the multilingual model underperforms on the counterpart of the monolingual model that has been stated on the previous references. Let's go for the first one, the cross-lingual model performance. The table itself is two verbose, so I'll summarize into the three key findings in XML. The first one is the number of models. As you can see on the very left side, the unicoders has been trained for each languages, so they have n models, while the XLMR is just trained on one single model that has been trained on multiple languages. We can see that the XLMR outperforms the unicoder. And the second one is the pre-trained dataset size and the number of languages that's being covered. When you see on the bottom two, the XLM has been trained on the wiki dataset, and it shows better performance when it covers the less languages. However, when you see the XLMR, it is being trained on the large dataset, which is Common Crawl, and it outperforms the XLM that has been trained on wiki and covers less languages, but XLMR covers more languages, like 100. The last one is the fine-tuned datasets, and XLMR shows better performance on the multilingual setup that is stated as a train all, while it shows lower performance on the cross transfer, which is the cross-lingual setup. Second one is NER, and the paper states that linear chain CRF takes advantages on this task, so we can get rid of the second row that is using the cross-lingual NER, cross-lingual CRF. Then we can see that XLMR that has been trained on each language shows the best performance, and even for the multilingual setup that is stated on the last row as an all shows on par performance. And as one could state before, that MLQA also showed the state-of-art performance compared to other models. That's all for the cross-lingual, and now I'm going to move on to the multilingual. Does the multilingual really underperforms on the counterpart of the monolingual models? By starting from the glue, we can see that XLMR that has been trained on 100 languages with single model that shows on-par performance compared to the BART or Roberta that has been trained on one single languages. But still there's some gap that has been like 1 on average or 0.2 on average. The paper states that this can be caused because of the cursive multilinguality and the vocabulation. But still, we can say that a multilingual model can perform well on downstream tasks. The next one is on XMLI, that we can see that two XLM models are trained in 7 languages that has been stated as XLM7. And for the BERT, that is trained on single languages and for the 14 different languages. You can see the XLM7 loses on cross-lingual setup, but it is advantageous to the BERT because it is trained on single language. And when we see the last row that is multilingual setting, the XLM7 wins on every languages and even on the average. So we can conclude that multilingual model can really outperform than monolingual counterpart models. And the last one is the low versus languages performance that XLMR's original subpool. When you see the 2 columns that stays as SW and UR, that are the low versus languages, shows like almost random initialized model performance for the model that has been trained on wiki, because they don't have enough training data set for that 2 languages. So when we change the training data set to the CC, that is a Common Crawl, then we can see there is a performance gain for every models. And when you even start up with the multilingual, then it shows the best performance compared to other models. That's all for the analysis, and we are going to move on to the recent works that second to this paper, and I'll hand it over to Jed.
Yeah, thank you. And to sum up, XLMR has strengths in various aspects. It achieves performance gains in a variety of cross-link or transport tasks, and it performs exceptionally well on low-resource languages. And it is competitive with strong monolingual models. However, there are issues concerning the dataset used for training. The dataset has not been released, and it may contain noise, irrelevant text, or duplicated documents. The dataset used in the paper is based on the Common Pro dataset, which is originally just a snapshot of the web obtained by randomly exploring and sampling URLs. In this paper, the data was refined using methods from CCNet, which contains identifying language, selecting high-quality sources like Wikipedia, or deduplicating documents. Subsequent research, such as OSCAR, slightly improved the filtering part of the CCNet, and it was freely available. It opened their dataset freely available. Following OSCAR, the study named Roots added the data obtained from the identified resources to the unidentified randomly crawled OSCAR data. Beyond dataset issues, there are also identified problems with the model itself. The